22nd problem. A circular sheet of radius 36 centimeters is divided into two sectors. Central angle of one sector is 120 degree. The sectors are rolled up into cones. What is the slant height of the cones? What is the ratio of the central angles of the sectors? Find the radius of each one. What is the ratio of the radii? Here, given that the radius of the sector is 36 centimeters and we know slant height of the cone is equal to radius of the sector. So the slant height of both the cones is 36 centimeters. Now we have to find the ratio of the central angles of the sectors. Given that central angle of one sector is 120 degree, therefore central angle of the second sector is 240 degree. Because the total angle is always 360 degree. Therefore, the ratio of the central angles of the sectors equal to 120 degree is to 240 degree. That is 1:2. Now we have to find the radius of each cone. Let me take the first cone. We know the relation x by 360 equal to r by l, where x is the central angle of the sector, r is the radius of the cone and l is the slant height of the cone. For the first cone, the central angle is 120 degree and slant height is 36 centimeters. Replacing the values, we get 120 by 360 equal to r by 36. Now look at the denominators, 360 and 36. When 360 is divided by 10, we get 36. So when 120 is divided by 10, we get the value of r, that is r equal to 120 by 10 or 12 centimeter. Or we can do it in another way also. We can simplify this. 3 120s are 160. So we can write it as 1 by 3 equal to r by 36. Now we can take 36 on the other side. So we can write r equal to 1 by 3 into 36. 1 3 is 3 and 12 3s are 36. So that is equal to 12 centimeter. That is radius of the first cone is 12 centimeters. Now let us look at the radius of the second cone. Again we can use the relation x by 360 equal to r by l. Here x is 240 and l is 36. Again look at the denominators. When 360 is divided by 10, we get 36. So when 240 is divided by 10, we will get the value of r, or r equal to 24. Or we can simplify, 2 120s are 240 and 3 120s are 360. Now we can take 36 on the other side and we can write r equal to 2 by 3 into 36. 1 3 is 3 and 12 3s are 36. 2 into 12 equal to 24. So the radius of the second cone is 24 centimeters. Now we have to find the ratio of the radii. The radii are 12 and 24. So the ratio is 12:24 or 1:2. 23rd problem. O is the center of the incircle of triangle PQR. Angle AOB equal to 110 degree. What is the measure of angle Q? Two angles of a triangle are 50 degree and 60 degree and the radius of the incircle is 2 centimeters. Draw the triangle. Given that angle AOB equal to 110 degree. In a circle, the angle between the radii through 2 points and the angle between the tangents at these points are supplementary. Therefore, angle Q and angle AOB are supplementary. Therefore, angle Q equal to 180 minus angle AOB, that is 180 minus 110, that is equal to 70 degree. That is angle Q equal to 70 degree. Now the second part. Two angles of a triangle are 50 degree and 60 degree and the radius of the incircle is 2 centimeters. Draw the triangle. When one angle of a triangle is 50 degree, then the angle at the center is 130 degree because the angle between the radii and angle between the tangents are supplementary. Similarly, another angle is 60 degree means angle at the center is 120 degree. So first of all, let us draw a circle of radius 2 centimeter. Now draw one radius, let it be OA. Since one angle is 50, the angle at the center is 130 degree. Take 130 degree and draw another radius, let it be OB. Now another angle is 60 degree, so angle at the center is 120 degree. So take 120 degree at the center and draw another radius, let it be OC. Now it is enough to draw tangents from the points A, B, C to get the required triangle. Take 90 degree at A and draw a line that is tangent to the radius OA. Similarly, take 90 degree at B and draw another line. Now take 90 degree at C and draw another line. Extending, we get a triangle. This is the required triangle. Since this angle is 130, this angle will be 50. Since this is 120, this angle will be 60. So we got a triangle with two angles 50 degree and 60 degree, and the incircle of the triangle is 2 centimeters. 24th problem. What is the sum of first 10 natural numbers? Sum of the first n natural numbers is 231. What is number n? Sum of n natural numbers is n into n plus 1 by 2. Therefore, sum of first 10 natural numbers is 10 into 11 by 2. That's equal to 55. Now, given that sum of first n natural numbers is 231, that is n into n plus 1 by 2 equal to 231. Taking 2 on the other side, we can write n into n plus 1 equal to 231 into 2. Or we can write n into n plus 1. Multiplying, we can write n square plus n equal to 462. Now taking 462 on left side, we can write n square plus n minus 462 equal to 0. Now we got a second degree equation where a is 1, b is the coefficient of n, that is again 1, and c is the constant term, that is minus 462. Let us find b square minus 4ac at first. B square minus 4ac equal to 1 square minus 4 into 1 into minus 462. 1 square is 1, minus into minus is plus, and 4 into 462 is 1848. So b square minus 4ac equal to 1849. Now let us solve the equation using the quadratic formula. N is equal to minus b plus or minus root b square minus 4ac by 2a. Here a equal to 1, b equal to 1, c equal to minus 462, and b square minus 4ac we got it as 1849. Let us replace the values. We get minus 1 plus or minus root of 1849 by 2 into 1. Let us find the root of 1849 at first. Let us make 1849 into two groups, 49 one group and 18 another group. Now take the first group 18. We know 4 square is 16, but 5 square is 25. So we can only take 4 square from this as 5 square is more than 18. So the first digit or tens digit is 4. That means root of 1849 is more than 40. As we know, 40 square is 1600. Now to find the unit digit, look at the group 49 and the last digit, that is 9. 3 square can be 9, again 7 square can also be 9. So the unit digit can be 3 or 7. That is, the square root can be either 43 or 47. How can we determine which one is the correct square root? For that, we know one thing, the tens digit is 4. Multiply this 4 by the next number, that is 5. 4 into 5 is 20. Now look at the first group 18, it is less than 20. So we have to take the smaller one, that is 3. So the unit digit is 3. That is root of 1849 is 43. Now replacing, we will get minus 1 plus or minus 43 by 2. That can be written as minus 1 plus 43 by 2 or minus 1 minus 43 by 2. Minus 1 plus 43 is 42, so it can be written as 42 by 2, and minus 1 minus 43 is minus 44, so it can be written as minus 44 by 2. 42 by 2 is 21, minus 44 by 2 is minus 22. Number of terms cannot be negative, so the value of n is 21. 25th problem. In the figure, angle Q equal to 45 degree, angle R equal to 30 degree, angle PSR equal to 90 degree, PR equal to 8 centimeter. What is the length of PS? Find the length of QR and QP. Draw a triangle with the ratio of the sides root 2 is to 2 is to 1 plus root 3. Look at triangle PSR. Angle R equal to 30 degree, angle PSR equal to 90 degree. Therefore, angle SPR equal to 60 degree. So, it's a triangle with angles 30, 60, 90. Therefore, the ratio of the sides is 1 is to root 3 is to 2. The smallest side is opposite to smallest angle. Therefore, PS is the smallest side, and largest side is opposite to largest angle. So PR is the longest side. Therefore we can write PS is to SR is to PR equal to 1 is to root 3 is to 2. Here PR is 8 centimeter and 2 into 4 is 8. So when we multiply this 2 by 4, we will get the value of PR. So in order to get PS and SR, we have to multiply these numbers by 4. That is PS equal to 1 into 4, that is 4, and SR equal to 4 into root 3, that is 4 root 3. Now let us look at triangle PQS. Angle Q is 45 degree, angle PSQ equal to 90 degree, therefore angle QPS is also equal to 45 degree. So it's a triangle with angles 45, 45 and 90. Therefore the ratio of the sides is 1 is to root 2. That is PS is to QS is to PQ equal to 1 is to root 2. Here PS is 4 centimeter, that is 1 into 4 is 4. So to get QS and QP, we have to multiply these numbers by 4. That is QS is 4 centimeter and QP is 4 root 2 centimeters. Now we have to find QR. From the figure, QR equal to QS plus SR. QS is 4 centimeter and SR is 4 root 3 centimeters. 4 is a common factor. Taking 4 outside, we can write 4 into 1 plus root 3 centimeters. Now let us try to find the ratio of the sides of this triangle. PR is 8 centimeter, PQ is 4 root 2 centimeters, and QR is 4 into 1 plus root 3 centimeters. The smallest side is opposite to smallest angle, and that is PQ. After that, opposite to 45 degree, that is PR, and the longest side is opposite to largest angle, that is 4 into 1 plus root 3. So let us first write the ratio of the sides. 4 root 2 is to 8 is to 4 into 1 plus root 3. Again, we can divide all the terms by 4. So we will get root 2 is to 2 is to 1 plus root 3. Now we have to draw a triangle with the ratio of the sides root 2 is to 2 is to 1 plus root 3. It's enough to draw this triangle. We know one side PR is 8 cm and the angles at the end are 30 degree and 105 degree. So in order to draw the triangle, first of all let us draw the side PR by taking 8 cm. Now at P, the angle is 105 degree. Taking 105 degree, draw a line. Now at R, angle is 30 degree. Taking 30 degree at R, draw another line. The point of intersection is the third vertex Q. So the triangle PQR is the required triangle. 26th problem. Draw the coordinate axis and mark the points A62, B26. Draw the square whose diagonal is AB. Write the coordinates of the other two vertices. First of all, let us mark the point 62. For that, draw a perpendicular to x-axis from the point 6 on the x-axis and draw a perpendicular to y-axis from the point 2 on y-axis. The intersecting point is 62. Similarly, draw a perpendicular from the point 2 to x-axis and draw a perpendicular from 6 to y-axis from the point 6 on the y-axis. The intersecting point is 2, 6. Now we have to draw the square whose diagonal is AB. First of all, let us draw the diagonal by joining A and B. Now to draw the square, draw a perpendicular from B to x-axis and A to y-axis. Similarly, draw perpendiculars and make the squares. The x-coordinate of every point on this line is 6 and the y-coordinate of every point on this line is 6. So the coordinates of this point is 6, 6. Similarly, the x-coordinate of every point on this line is 2 and the y-coordinate of every point on this line is 2. Therefore, the coordinates of this point is 2, 2. 27th problem. In triangle ABC, angle B equal to 90 degree, AB equal to 8 cm, BC equal to 6 cm. O is the center of the incircle. What is the length of AC? Find the area of the triangle. Find the radius of the incircle. Given that AB equal to 8 cm and BC equal to 6 cm. Also given that ABC is a right angle triangle. Therefore, AC is its hypotenuse. And we know hypotenuse square equal to base square plus altitude square. Or hypotenuse equal to root of base square plus altitude square. Therefore, AC equal to root of 8 square plus 6 square. Here 8 square is 64 and 6 square is 36. So we can write it as root of 64 plus 36 and that is equal to root of 100 and that is equal to 10. That is the length of AC equal to 10 cm. Now we have to find the area of this triangle. We know area of the triangle equal to half BH. Here B is 6 and H is 8. So we can rewrite it as half into 8 into 6. Half into 8 is 4 and 4 into 6 is 24. So the area of the triangle is 24 centimeter square. The sides of the triangle are 8, 6 and 10. We need to find the radius of the incircle. Let us find the perimeter of the triangle at first. That is 8 plus 6 plus 10 or 24 centimeter. Now let us denote half the perimeter by S. Then S is equal to 12 centimeter. Now we know the radius of the incircle of a triangle is its area divided by half the perimeter. That is R equal to A by S. Here A, the area is 24 and S is 12. So radius equal to 24 by 12, that is equal to 2. That is the radius of the incircle equal to 2 centimeters. 28th question. In the figure, AB is the diameter of the circle, angle DPB equal to 90 degree, AP equal to 3 centimeter, PB equal to 1 centimeter. What is the radius of the circle? Find the length of PD. Draw an equilateral triangle of side 2 root 3 centimeter. Given that AP is 3 centimeter and PB is 1 centimeter. Then AB equal to 3 plus 1, that is equal to 4 centimeter. Now AB is the diameter of the circle, therefore radius of the circle equal to 2 centimeter. Now we have to find the length of PD. We know PA into PB equal to PD square. Here PA is 3 and PB is 1, therefore we can say 3 into 1 equal to PD square or PD square equal to 3. Therefore, PD equal to root 3 centimeter. Since PD is root 3 centimeter, PC is also equal to root 3 centimeter. Because we know CD is a chord and AB is a diameter which passes through the center. And AB is perpendicular to CD. Therefore, this AB bisect the chord CD. That means PD and PC are equal. Therefore, CD equal to 2 root 3 centimeter. Now we have to draw an equilateral triangle of side 2 root 3 centimeter. Here we have seen that the length of CD is 2 root 3 centimeter. So it is enough to draw an equilateral triangle with side CD. First of all, let us draw AB equal to 4 centimeter. Now mark a point P 3 centimeter away from A. Now we have to find the midpoint of the line AB. For that, let us draw the perpendicular bisector of AB. For that, take more than half of AB and draw an arc from A on both sides of AB. Similarly, take the same radius and put the compass at B and draw arcs on both sides. Mark the points of intersections and join them. This is the perpendicular bisector of AB and it passes through the midpoint of AB. Now put the compass at this midpoint R and take radius equal to RA and draw a circle. Now take 90 degree at the point P and draw a line so that it touches the circle at 2 points. Now we know PA into PB equal to PD square. So the length of PD is root 3 centimeter and therefore the length of PC is also root 3 centimeter and therefore the length of CD is 2 root 3 centimeter. Now we have to draw an equilateral triangle with one side CD. Take CD in the compass and draw an arc from C. And then draw an arc from D, taking the same radius. Mark the points of intersections. Join that to C and D. So the triangle CDE is the required triangle. 29th problem. Read the given concept carefully and write answers to the following questions. Each question carries 1 score. In the figure, angle B equal to 90 degree. Then what is angle A plus angle C? Sum of the angles of a triangle is 180 degree. So the sum of the acute angles of a right triangle is 90 degree. That is, if angle A equal to x, then angle C equal to 90 minus x. Tan A equal to BC by AB. Tan C equal to AB by BC. Tan A into tan C equal to BC by AB into AB by BC. That's equal to 1. As the angle measure increases from 0 to 90 degree, tan value is also increasing from 0. Tan 0 equal to dash. If tan A into tan C equal to 1, then A plus C equal to dash. Tan 1 into tan 89 equal to dash. Tan 45 equal to dash. If tan x equal to tan 90 minus x, then x equal to dash. Tan 1 into tan 2 into tan 3 into etc. into tan 89 equal to dash. Given that as the angle measure increases from 0 to 90 degree, tan value is also increasing from 0. That means tan 0 equal to 0. And as the angle increases, tan value also increases. Now the second problem, if tan A into tan C equal to 1, then A plus C equal to 90. We have seen that tan A into tan C is 1, then A plus C equal to 90. Tan 1 into tan 89 equal to 1 plus 89 equal to 90. Therefore, they are a pair of acute angles in a right angle triangle. Therefore, tan 1 into tan 89 equal to 1. Tan 45 equal to 1. If tan x equal to tan 90 minus x, then x equal to 45. 45 equal to 90 minus 45. Therefore, x equal to 45. Tan 1 into tan 2 into tan 3 into etc. into tan 89. Let us make them pairs. That's equal to tan 1 into tan 89 into tan 2 into tan 88 into tan 3 into tan 87 etc. into tan 44 into tan 46. Now tan 45 remains into tan 45. 1 plus 89 equal to 90. Therefore, tan 1 into tan 89 equal to 1. Similarly, tan 2 into tan 88 also equal to 1. And like that, tan 44 into tan 46 also equal to 1. And lastly, tan 45, that is also equal to 1. So, we get this is equal to 1 into 1 into 1 into extra, and that is equal to 1.